Welcome to the Sam and Rachel Radio Hour, where today we'll be doing experiment 3.5, which is a single replacement reaction of zinc and hydrochloric acid.
Yay!
To begin, we will take our 150 milliliter Erlenmeyer flask. And what will we add to that flask, Rachel?
To that flask, we're going to add 15 milliliters of 6 molar hydrochloric acid.
Great. Now let's add that 15 milliliters. Now what will we do with the flask, Rachel?
We're going to put a stopper in the flask so we can close the system, because in this reaction we're going to be dealing with gas and we don't want it to escape because we need to measure the pressure of the gas.
Yes. Now what we will do is, in order to measure the pressure and temperature increases or changes that may occur, we're going to add a pressure gauge and a thermometer.
Mm-hmm.
Now let's add our other reactant. What's our other reactant, Rachel?
Our other reactant is zinc, and we're going to add 0.25 grams of zinc.
That's great. Now, as you can see, a reaction is occurring.
Yes, there are bubbles forming.
Which tells us there's most likely a gas forming.
Yes, and the temperature has gone up too. And our pressure has also had an increase.
Yes. Our pressure was initially 1 atmosphere, but now we can see it as 1.7 atmospheres. And our temperature was originally 21.5 degrees Celsius, and it is now more than that and slowly cooling. So while it cools, we will explain what reaction is actually occurring here.
Yes. So in this reaction, we have 1 mole of zinc solid reacting with 2 moles of hydrochloric acid, which is aqueous, to form 1 mole of zinc chloride, which is aqueous, and 1 mole of hydrogen gas.
And what type of reaction was this, Rachel?
This is a single replacement reaction. Do you want to explain what that
I would
is to our
absolutely love to explain the term single replacement reaction. A single replacement reaction is what happens when you have 2 initial reactants and one of them is a compound, and that compound disassociates into 2 ions, and one of those ions reacts with the other initial reactant to form a new compound, and then the other ion is left on its own to bond with itself. In this case, our initial compound was hydrochloric acid, which dissociated into hydrogen ions and chlorine ions. And the chlorine ions bonded with the initial zinc we had to form zinc chloride, and then the hydrogen ions bonded with themselves to form hydrogen gas.
Beautifully put, Sam.
Thank you, Rachel. Now, in order to continue this reaction, we must wait until the temperature is within a half a degree of the room temperature, which was 21.5 degrees Celsius.
We're almost there.
Yes. Next, once that happens, we will take our gas syringe, which is slightly off screen, inconveniently. We will take this gas syringe, and then we will place it in the flask so that the gas formed, which was the hydrogen gas, can expand into the syringe, and we can observe how much volume was added to the system.
Very cool.
Yes. And also, we can observe, now that it's 1/2 degree, that our pressure is still at 1.69 atmospheres. And when we add the syringe, it will reduce and normalize down to 1 atmosphere.
Yes, and we will have a certain volume of gas in our syringe as
and
well.
that volume added is 92.5 milliliters. All right, and that was our single replacement reaction of zinc and hydrochloric acid. Now we will properly dispose of all materials. We love you.